Hello, everyone, and welcome back to another episode with your girl, Audrey Codner-Gibson from ACG Math Tutoring. How are you doing? So I'm so glad to see that you are here for another episode of finding out how to do math. All right, so hopefully you guys are getting yourselves together because I'm ready to get started. And welcome back. So what we're going to work on today is simplifying those radical expressions. Yes, we have moved on from rational. Now we're going into radical expressions. So we're going to look at our Common Core standards of A-APR 0.7 and A-REI 0.2. So before we touch on to that, we're going to look at the review of the exit ticket from last time. So we just finished up that unit. And if you are new to my channel, I just want to give you a quick briefing of what we normally do. We normally just go through the chapter, go through some guided practice, also look at the exit ticket at the end, and the very next video is when we review our answers of that previous exit ticket. So hopefully you're going to be able to sit down and relax and enjoy the thing called math, right? So in order for us to solve this problem, we need to figure out what the lowest common denominator is. So we have 3 and we have 7. So if we take a look at our 3 times table, so we got 3, we have 6, 9, 12, 15, 21, and so on. So in 24. Okay, we'll do that. So now for the 7 times tables, you have 7, you have 14, you have 21. So far, we can keep going, 28, all right? But what is the lowest number that they have in common? Hopefully you are saying 21. So that's what we're going to use to multiply the entire equation so we can get our answer or try to get our x's by itself. Sometimes you just get tongue-tied, you know? Talk so much. So we have our 21 over 3. So what we're going to do is call a cross simplification. So we're going to cross simplify. So it's like saying 21 divided by 3, which gives me 7. And then what's left over is being multiplied by that 7, which is x. Plus, now we got 21 divided by 7, which is 3. And that's being multiplied by what's left over, which is also an x. And equals, so we got the 21 times the 10 because they're both whole numbers. So when we multiply that, we got 210. So now we're going to combine our like terms. So we have 7 times x, which gives me 7x. And then 3 times x gives me 3x. And since they're both the same or like terms, we can go ahead and combine them on that same side, which gives me 10x. And then I just bring down the equals to 10. So now I'm dividing both sides by 10. And here's my secret when I divide both sides by numbers. That can cross out. So 0 and 0 can cross out. So now I got 21 over 1, which is just simply 21. So my x value is going to equal 21 to give me that true statement. Because if I do 21 divided by 3, I get 7. If I had 21 divided by 7, I get 3. 7 plus 3 equals 10. All right? So, but for today's lesson, you should be able to say to yourself, I can simplify radical expressions using square roots and irrational numbers. So irrational numbers, remember, the square root of 2, that's an irrational number. Pi, that's an irrational number. E, that's an irrational number, okay? So we're going to be using those square roots. We're going to use some more irrational numbers in order for us to simplify our radical expressions. So we're going to be doing some guided notes, some examples, some practice problems, and at the end we will have an exit ticket. So here's some helpful hints. So a lot of these were discussed in my previous videos. So I will try to link that video onto this one as best I can. But if not, you can definitely go onto Front Porch Tutoring with Miss Codner-Gibson. if you ever want to see the rest of the videos of this series. But one of the things that we need to look at is those helpful hints. So the square root of a squared is equal to a. And the reason why the square root and the squares, they're inverses of each other. They cancel each other out. Just like addition is the inverse of subtraction, and multiplication is the inverse of division. But if you do have a number that's not evenly, not a perfect square root, that means you can split it up. So you split it up, square root of a times b will give me the square root of a times the square root of b. Now, if you don't have a perfect square, try to hit my perfect prime combination. Instead of the perfect prime, it's the perfect prime. So let's look at a couple examples because I think that will help glue everything together. So we got the square root of 27. Now 27 is not a result of a perfect square. So if a perfect square is going to be like 1 times 1, or 2 times 2, 3 times 3, okay? No matter how I continue it on, none of those is going to give me 27. It'll give me a number either lower than 27 or above 27. So we want to look at our perfect prime combination. So that means I can break that 27 up. One is going to be a perfect square, or perfect square root in this case, and the other one is going to be a prime number. So remember, a prime number is only divisible by itself and 1. And the first prime number is 2. 1 is not a prime number, okay? I know, we're so like focused with that. The first prime number is 2 because the only way you can get 2 through multiplication is when you multiply 2 and 1. If you notice, when you look at all the prime numbers, it always has a number 1 involved. 1 is actually composite. I know, it's crazy, but here we are. So 27, what can give me 27 that's a perfect square? So I can use 9 and 3. Because the square root of 9, that's going to be 3. Because 3 times 3 gives me 9. The square root of 3, that's that irrational. Because if I try to put in the calculator square root of 3, I am not going to get an even number. So 3 square root of 3 is my solution for simplifying the square root of 27. Okay, all we're doing is breaking things down. So now the square root of 36, x squared y, we can use that separation part to help us out. Meaning, I'm going to give each of those items their own radical. So now I got the square root of 36, which is 6, because 6 times 6 gives me 36. Now remember, a square and a square root, they're inverses of each other. That means they cancel each other out, which leaves me with x. And the square root of y, that's already there. That's my irrational. So that comes on down. So my final solution, if I may clean it up a little bit, is 6x. You know, make sure they like each other. 6x square root of y. Okay, for number 3, we have a 3 on the outside, so we're multiplying that radical. So we have our m, made this a little bit long, and then square root n squared. Okay, so that square doesn't go for both the m and the n, it's just the n. I know I'm like working it out here. All right, so we have 3 times the square root of m. Square root of m, we can't break down. So if I can't break it down, I bring it down. But the square root of n squared, we have inverses of each other. So that means that n is no longer underneath the radical. And then what do I do with the 3? I just bring it on down. Because I'm multiplying that 3 to the other number that's not underneath the radical, which is our unknown n. So we have 3n radical m to figure that out. So let's go with 4 and 5. So we can do the same split. So we got the square root of 125 and then the square root of x cubed. So 125, you're probably thinking, oh, it ends in 5, so it has to be 5. No, because 5 times 5 gives me 25. So that element of 25 is involved in it. But 25 times what will give me 125? If I need 4 quarters to give me a whole dollar, and I need another quarter, so it's going to give me 5. All right? So 25 times 5 gives me my 125. The square root of 25, as we mentioned, it is 5, but this radical 5 has to stay. It can't be broken down. So this is where it comes with my perfect prime combination. But we're not done. We have the square root of x cubed. And you're probably like, well, there's an x squared in there, because remember, x cubed is the same as saying x times x times x. So that means there's 2 x's that we could break out of there as its own perfect. So we can do this x squared, and then we have that 1x that's left over, so it'll have its own radical. Now take a look. Remember, the square and the square root, they cancel each other out. So that gives me x, but then we have our square root of x over here. If it can't be broken down, bring it down. So now, this is basically our answer, but let's clean it up a little bit. Let's combine everything that's not under a radical together, which is my 5x, with everything that is still under a radical, which is my other 5x. So my answer is 5x radical 5x. Okay, so all we're doing is breaking it down. So if it's a cube, you know, if I have 3 of them, I know I can group 2 of them and pull them out. Okay, I know I'm going to get 1 whole of them pulled out, and there's going to be 1 still left under the radical. So when I see an odd number, what happens is I'm going to pull 1 of my x's out and 1 of my y's out, and this is telling me that I still have an x and a y left under. So when it's even, you can easily cut it. You can easily cancel it out and then take out the radicand, which is the number underneath. So this is my solution for number 5. I know, right? So I want you to practice. Okay, give it a try. So we have the square root of 50x squared, y squared, z cubed. Sorry, had an itch. Then we had 5 times the square root of 18, x to the 4th, y cubed. So go ahead and give it a try, and I'll just shut up. All right, so let's break it down. I'm so silly sometimes. I'm so sorry. Like, I'm supposed to be all professional and everything, but, you know, it happens. All right, so I'm giving everything its own radical. Right now, my computer wants to be weird. All right, so square root of 50, is that a perfect square root? So we can break that down into the square root of 25 and the square root of 2, because 5 times 2 gives me that 50. Square root of 25 gives me 5. Bring down the square root of 2. Now, if it's an even number, that means the square root and the square are going to cancel each other out. So what's left is a y and an x. That came from that. That came from that. So now z cubed, it's an odd number, but I know I'm going to have 2 of my z's which I can pull out to make it into 1z, but then I have 1z left under the radical. So now this is basically our answer, but let's clean it up. So starting with the number, so we have 5, alphabetical order, x, y, z, and now what's still left under the radical is my 2z. So we have 5xyz times square root or radical 2z. So now for number 2, we have our 5 that's just coming down for the ride. I'm going to break down my square root of 18, x to the 4th, square root of y cubed. So square root of 18, that needs to be broken down. So what is my perfect prime combination? So we got 9 times 2, because the square root of 9 gives me 3, and the square root of 2, that's irrational. We can't break it down, so I bring it down. The 5 that's out here, that's going to come down as well, and that's multiplication. So we have the square root of x to the 4th. 4 is an even number. So basically, all I have to do is just take half of 4. Because if I take half of 4, because remember, I'm going to have x squared times x squared. So I have 2x squares. If they are both under their own radical, that means that's going to cancel out, that's going to cancel out, which gives me x times x. So an easy way to remember this, if it's an even exponent under the radical, divide by 2. Okay? If it's odd, pull 1 out and then leave 1 in. So we have x to the 4th, so that will give me my x squared. Now, there's an odd number, so that means we have the square root of y squared times the square root of y, okay, which will give me my y, because the square and the square roots cancel out, and leave me behind with another square root of y. So let's clean it up. We have 5 times 3, which gives me my 15, x squared, y, and then square root of 2y. All right, so a lot of it deals with the multiplication, but I really think that through practice, you can simplify those radical expressions using those square roots and irrational numbers. So we did look at the exit ticket from last time. We definitely looked at some guided notes and definitely looked at some examples. We got those practice problems. So now let's work on the exit ticket. So you have one problem I want you to simplify. So the square root of 16y cubed, z cubed. All right, so see if you can break that down. And like always, if you like these videos, go ahead and hit the like. If you want to subscribe to my channel so you know when these videos are going to come out, that'll be awesome. If you want to hit the notification button to really know when it comes out, hey, knock yourself out. But please definitely share, because I want as many students as I can possible to really just absorb the fact that they can do math. I don't know who put it in our minds that we can't do math, but you can. It's going to take a step-by-step process, but if you're willing to learn, I am more than willing to teach. So if you want me to be your private tutor, please get in touch with me. I will leave my information at the end of this video. Go ahead, email me, check out my website, or maybe even call me. I mean, I'm available, but there are some other people that are getting tutoring. So if I don't answer my phone right away, and plus they don't call me at like 12 midnight because I'm asleep. I had a long day. So hopefully you guys are doing all right and everyone is doing perfectly well. Thank you so much for your time and attention, and I will see you next time. Bye.